G'day, I'm Yuki-san Dev, and in part 18 of this series, Unity for the Absolute Beginner, we will be revisiting scripting basics and tidying things up. Well, we've got to the 18th video and done quite a bit of scripting, but I haven't spent much effort keeping the scripts tidy and following certain standards. So in this video, we will revisit scripting basics with some more explaining. Just basically some things that haven't been covered so far in the series. I won't go into too much detail on each item, but just enough to get you through as a beginner. Then in the intermediate series, we will revisit this again. This is probably going to be mainly theory, so I hope it doesn't bore you too much. But as a beginner, it's good to run through it. Especially if later down the track you start developing a game with others to help you. Chances are quite a few of them would have learnt these fundamentals, and it makes things a lot easier in code if you're all doing it the same way. So with all that said, let's get into it. Alright, so we will start with naming conventions, or standards if you like, in Unity. Now there really isn't a rule here. I mean, you can name things as you like and they will still work. So the following is just more of a guide than anything else, but you'll find less headaches if dealing with other developers that have learnt at schools or are just particular about doing something right. So let's jump right in. So firstly, C# script doesn't like spaces very much, so when declaring variables, the usual way to separate words in names is with capital letters. So you will more often than not find variables declared with a lowercase to start it off and then a capital to start the next word. So the variable player name would be written like this, or player high score written like this. In the C# world, this is commonly called camel case. You will find other styles of declaring variables, but this one you'll probably see the most often. Another one that some like is the Hungarian notations, pretty kind of old school, which is just putting an abbreviation of the variable type in front of the variable name. Some people still like it, I guess. So the player name would become str, player name, because it's a string, and player high score would become something like int, player high score, because it's an integer. Now for methods or functions and classes, Pascal seems to be the preferred way to do it. Pascal is just like camel case, except the first letter is also capitalized. So a custom function like getRandomNumber is capitalized at the start too. For custom functions, Visual Studio will actually remind you that your naming style is a little bit off, but it will still work. And you can see that the start and update methods are also capitalized at the start, and also the monoBehavior class is capitalized at the start. Notice the using statements like the Unity engine also is in Pascal. Pascal generally is also the general preferred choice for naming objects and scripts in your project as well. So, can you see a pattern here? It's generally a mix of Camel and Pascal. There is more to it if you want to get crazy, but generally it doesn't really matter how you do it as long as you or anyone else working on your project are comfortable with your style. And don't worry, if you do write something that is case sensitive, then Unity will be pretty quick to tell you about it with an error. Alright, now talking of naming things, also remember to name things in such a way that you or someone else knows what the variable or function, etc. is all about. Try not to abbreviate too much. For player score, for example, it might save you a second or two just using PS, but it might be a tad confusing and not very practical once the game got bigger, and you would be having to put rem statements all over the place to remind yourself or others what the variable is for. Also, it's recommended that you throw verbs in the names for bools, which are of course variables that can only be true or false, so the names should kind of reflect that. Prefixing the name with is or has, etc. is more like asking the question. For example, rather than game over, you would use is game over. And then the bool is answering the question. Now, something else when declaring variables, if you have a few of the same variable type, you can actually put them all in the same line, separated with commas, like so. I'm personally not a big fan of doing this, but I just thought I'd let you know that you can. And you also remember at the end of most lines of code, you have to put a semicolon to mark the end of the code. Well, you can also write several lines of code on one line as well. Not the most practical thing in most situations, but hey, who knows. Now, just back to functions or methods. I already have a video on them, but just a quick note, do use them to keep things tidy. They are awesome for repetitive tasks to save you time by not having to type in the same code multiple times. Like a random number generator with parameters can return a random number between whatever parameters are sent to it. So here, for example, I have 2 lines both using the same function to get different numbers in different ranges. It saves having to type in the same code twice. You could even store some functions that you plan to use in many other scripts in your game in one static script, so you could call on them anytime. Now, just one other note is I call them functions while others might call them methods. There seems to be a little debating as to the name, but because I'm pretty old school, I call them functions. Whilst things like start and update I might call methods. Alrighty, now onto the biggie. Private, public, and serialized, and get set. Now, I was going to cover this in a separate video, but I think it's okay in here. And besides, it's along the lines of today's subject of rights and wrongs. So throughout my series so far, I have used public and private pretty loosely. There are some best practices for this. Firstly, the number one rule is, if it doesn't need to be public, then keep it private. The most common mistake with most beginners is that they just make everything public. It's understandable, it makes things easier, right? You can see everything in the inspector, etc. Yes, but the problem is that if it's public, it's not only visible in the inspector, it's visible in the entire game. The entire game has access to it. So let's say you made a few public variables to control the speed and rotation speed of something that can move, so that in the inspector you can change the values to get them just right. Well, after you're done and you've got the speed and rotation just right, then make those variables private. However, if you really want to see it in the inspector indefinitely but still have it hidden everywhere else in the game, then there is a way, and it's something I haven't covered so far in the series. It's making the variable serialized using SerializeField. So a public field is actually already serialized while a private one is not. But you can make a private field serialized by putting SerializeField in square brackets above it. Now you can see it in the inspector for the objects it's attached to, but the rest of the game cannot see it. The SerializeField will serialize everything on the line below it, so yep, you could list several variables in a single line and they will all be serialized. Also note that you can put SerializeField on the same line as the variable that you want to serialize as well. Now, there are some things you can't serialize, and I will leave that to you to find out. Best resource for all this kind of stuff is, of course, at docs.unity3d.com, and I will leave a link in the description for that. And now, there is another level more centered around protecting your variables. So, what say you have a variable that you want other scripts to be able to access, but you want to set up rules to keep the variable safe. You are creating the game, and you have ideas, and you don't want your collaborators messing it up. So introducing get and set. Using get and set changes the variables into properties, so a slightly different method is required to access them. Now there are quite a few scenarios where you could use these, but I'll go through a few simple ones. So let's say you have a force field duration variable to control how long the player can keep a force field. And the way your game is structured, you want to keep that force field a certain value, but still make it available to other scripts to read. Let's say you want the force field to be 5 and stay that way. So public int force field duration won't do because that can be changed from anywhere. Private's no good because nothing can see it. So we are going to use public int force field duration, and then in curly brackets we're going to put get and a semicolon, and then of course the variable value. So get, as you would imagine, is restricting it to be only read from. This basically makes that variable read only. We can only get from it. This variable can now only be read by other scripts, of course. That's great if you want it, but it can only be read from this script too. So we need to change that. Let's try public int force field duration get again, but this time we're going to add private set. Now this is still only read only for the rest of the game, but we can write to it from within the script, hence the word private. Now one more scenario. Let's say you do want to allow other parts of the game to alter force field duration's value, but you want to set some rules for it. So you have the force field duration set to 5, but the way you have the game arranged is maybe you wouldn't want the force field duration to be any longer than, let's say, 8. Well, you can set a rule that will only allow the variable to be changed if the variable is less than 8. So first you would create a private and protected variable, I always prefix my protected variables with a p and an underscore. It's just basically short for protected. So private p underscore force field duration. Then I would make a public variable for all to see. This variable isn't really holding the value, it's just the one we're going to use for validation. Kind of think of it as a middleman. So public int force field duration. And then underneath that particular variable, we are going to put our gets and sets. So the first one is going to be get, which is return p underscore force field duration. So when another script requests the value from this variable force field duration, the get method will actually return the value from p underscore force field duration. And now for set, the code would look something like this. So we are saying if something tries to change the value higher than 8, then don't change it. Otherwise, if it's below 8, change p underscore force field duration to the value that it's trying to be changed to. It's always a good idea to put debugs in there so you can, for one, check that you've got the flow of the script right, and also to remind the other dev that the value is out of range. So this script here, for example, is going to try and change the value to 9. Watch what happens. We get the debug lines telling us it's out of range and the variable remains at 5. Now let's try and change it to 7. And run. Cool. Changed to 7 because it was within our rule. Now there's lots more to this, but I'll stop here with the get and set for now. It might take you a minute to get your head around. And of course, all these different scenarios might require different techniques and choices between public, private, serialized, and get set. I will publish the code from this video in my GitHub too, if you'd rather just grab that and take a look. Now, one other quick thing in scripts is references. That's those little grey lines above the functions and methods and classes and things. They can be handy to find out what is referencing your class or function. I have the script that we just used called otherscript.cs trying to change the force field duration in the script. So when I click on the reference for this class or script, I can see that otherscript.cs is accessing the script. Then if I look at my public integer force field duration, I can see exactly what code is being used in otherscript.cs. This can also be useful when debugging your game and maybe a value is changing for no reason. You can check to see what in the game is accessing the script and possibly changing it. Alrighty, well, while we're on the subject of debugging, let's revisit debug.log. You will find yourself using this all over the place to follow the flow of something and or to look for a bug or a stopping point. Quite often you can find yourself with 0 errors when you run the game, but something isn't working quite as it should. Debug can usually help. So a possible scenario could be I have a prefab that I would like to instantiate into the scene at a random X location. I created a function to do the spawning and then used invoke repeating to instantiate a ball every half second. Should be okay by the looks of things. Let's run it and see. Well, that's weird. It's spawning in the sphere instances, but I only see 1. Well, let's get back into the script. The instantiate line looks okay. Xpos is a random range. Nope, can't figure it out. Let's put a debug in the code to see what's going on. Debug.log xpos. And let's save. And run. Hold the phone. Xpos is 9.5 for every instance created. So something must be wrong with my random statement. Let's get back in the script. Yep. So I'm getting a random number between spawn pos and spawn pos. It should be between minus spawn pos and spawn pos. I forgot to put the minus sign in. Duh. And save and run. There we go. Problem fixed. Let's try one more. Let's say I've got the same setup, but this time I only want to spawn in a max of 5 enemies. Looks all good. Let's run it. Nothing is spawning. Damn. Back into the script. I don't know what the heck is going on here. Is my function even running? Let me put a couple of debugs in here to find out. So before the if, I'm going to put debug.log running function spawn enemy. And inside the if statement, I'm going to put debug.log inside if statement. And save. And run. Hang on a second. It's running the function, but it's not running what's inside the if. Ah, crud. I think I know what it is. Back in the script. Yep, just as I thought. I used the greater than sign. Should have been the smaller than sign. And save. And run. That's better. Now spawning in the enemies, and it stops at 5. Cool. Now, of course, these examples are crazy simple, and you probably would have already figured out the problem just by rereading the code. But imagine much more complex situations with hundreds of lines of code. Debug is going to help you. Alright, I think that will do for this video. It's kind of a mixed bag of stuff in this one. I was going to cover common errors in this video, but it's getting a bit long, so I'll do that in a future video. And just a reminder, I will publish the code from this video in my GitHub too, if you'd like to grab that and take a look. I'm not sure what's up for the next video, but I think it might be game time pretty soon, incorporating everything so far in the series, plus a little more. So, I hope to see you in the next video.